Today we are going to be learning about how solubility plays a role in biology as a part of my CCI project. So we first have to learn what solubility is before we can really understand how it plays a role in biology. So solubility is the maximum amount of a substance that can be dissolved in a solvent. And so sometimes a precipitate forms out of this combination, and a precipitate is a solid that is formed after a solute and solvent are combined. So here we have the solute is the thing that is being dissolved in the solvent is doing the dissolving, and then after that we have a solution. So what are minerals? Minerals are elements in the body needed to facilitate reactions or form structures. So for examples, minerals can be carbon, nitrogen, hydrogen, oxygen. There are two types of minerals, macrominerals and trace minerals. So macrominerals are needed in large amounts, and these are elements like calcium, phosphorus, sodium. But trace minerals are not needed in large amounts, so these can be zinc, iron, selenium, small things that you need to survive, but not as much as calcium. What are vitamins? So vitamins are a little bit different because they are organic molecules that are essential micronutrients. So there are two different types of vitamins, and unlike minerals, it's not macro and micro, it's actually fat soluble and water soluble. So fat soluble vitamins are obviously vitamins that are soluble in fat, so they can be dissolved in fat. And these vitamins are vitamins A, D, E, and K, and you can get these vitamins through fish oil pills, which have vitamin A in them. And then water-soluble vitamins are vitamins that can be dissolved in water, and these are vitamins C and B. And a lot of citruses, like orange, has vitamin C in it. Why is solubility important to vitamins and minerals? So when they enter the body, vitamins and minerals have three fates. They're either used immediately, stored in the body, or excreted through the body. And these vitamins and minerals have to be broken down to extract the nutrients and be dispersed within the body. So if vitamins and minerals were not soluble in water or fat, then they wouldn't be able, the core part of them that we need for our body, the nutrients out of them, would not be able to be dispersed and used effectively. And so, for example, some nutrients are carried by the blood throughout the body. How can we tell if a mineral compound is soluble in H2O? So we follow our solubility rules. So, for example, calcium carbonate is non-water soluble, but sodium chloride is. Polar, if the compound is polar, then it's soluble in water, and it forms an aqueous solution, which means that it's something dissolved in water. And if it's non-polar, then it's soluble in fat. Why is solubility important to biology as a whole? So biologists studying the extraction and distribution of nutrients throughout the body from vitamins and minerals can easily determine which nutrients are stored in the body's fat and which are used immediately. So again, most of the time, if they are fat-soluble vitamins or minerals, then they are stored most of the time. And if they are water-soluble, then they are used immediately. Thank you. And this is coming to my Google Slides presentation. And then these are my sources. So, cool. Thank you.